Hi everyone, welcome back. So GFG problem of the day today is Kth smallest. So moving to the question, we are given an array ARR and an integer k where k is smaller than the size of the array. The task is to find the kth smallest element in the given array. It is given that all array elements are distinct. So first of all, it says that we have to solve it without using inbuilt sort function, but this just says it our program will not stop it. So we can do this if we get it somewhere in interviews and all. The compiler will give us the scores. So kth smallest element, the question seems very easy. We can sort it in ascending order and then find the kth and return the kth element. So this is the simplest solution for all. So this is the simple Java solution. We can sort the R array using arrays.sort and return the k minus 1 because k means index will be k minus 1. We shall return that element and it will be the kth smallest element. Now how to do this without inbuilt sorting? Let us see another approach. So how shall we do this without inbuilt sorting? Sorting means n log n minimum time complexity. If we see sorting, merge sort or quick sort, and log n will be the minimum time complexity. How to reduce this time complexity? So first of all, if we see, we need only the kth smallest. We do not need other elements that are whose position is greater than kth element. So we do not need them. So if we use a priority queue or a heap structure, then we can keep only k elements and leave the rest. So our search time complexity will reduce to n log k because we are keeping a heap of size only k. So that will reduce the time complexity. How shall we do it? Let us see. This is we are reducing the time complexity from n log n to n log k where k is the kth smallest term. So we shall keep a priority queue. We have to find the kth smallest term. So we have to keep our queue in descending order so we get the larger elements so that we can remove them, check and remove them. We want the greatest number on the top, so we are keeping the priority queue in descending order. So we have passed a comparator and written I2 minus I1 to make it descending. Now we have made a queue. Now we shall put a loop on the array. Now till our queue size is less than or equal to k minus 1, we shall just add it because we can get k elements. So till our size is less than equal to k minus 1, we shall add elements. Now after, if our loop does not, if condition is not true, that means our queue has k elements already and new element is coming. So we shall check if it is less than q dot peak, means our q peak is greater than the ith element. We want the smaller element, so we shall remove the greater element and add the current element which is smaller than the greater element in the queue. So after this loop, our queue will be having k smallest numbers of the array, and on the top will be the kth smallest. So we shall just return q dot poll, or the topmost element. The kth smallest element will be on the top. So this was the solution using the priority queue, simple solution, and the complexity has reduced to n log k. But how shall we reduce more? The question says expected complexity is n plus max element. So how shall we do this? One more thing that we have read of is counting sort. Now if you see, our array elements can only be up to 10 to the power 6, and one tricky thing in the question is all elements are distinct and there can be 10 to the power 6 elements. So we can just keep a Boolean array till 10 to the power 6 and keep put a loop on the array, and if and on that index we shall put true if it comes in the array. and after that we shall just count which is the kth smallest. So this is the other approach, or the third approach to our solution. How shall we do it? We have kept a boolean nums array to 10 to the power 6, and 1 we have added extra so that 10 to the power 6 can be accommodated. Now we have put a loop on the array, and that index we have made it true, means that element is available. Now we just have to find out the kth index element. So initially kth index is 0. Now we have made a loop. If that element is present, if it is true, now we increase the kth index. Now if k index is equal to k, means that element I is our kth smallest element, so we have to return that. So this is the kth smallest element I, we have returned it. If we come out of the loop, means we do not have, but this condition will never arise according to the constraints. So this was the third approach, third solution for our question without using inbuilt sort function, and its complexity is till on or till max element, because we are putting a loop till 10 to the power 6 and is in that range. So this was the solution. I hope you guys would have understood it and liked three approaches. I hope it would help you guys. Thanks for watching the video. Please like and subscribe. Thanks. Have a nice day.